Hello and welcome to our lesson on radicals multiplying, a more advanced look. First, let's talk about the rules for multiplying. In order to multiply a radical expression, you need to multiply like terms. Remember, any whole numbers are considered to be like terms to other whole numbers, and any radicands are considered to be like terms to other radicands. You can't take a radicand, though, and multiply it by a whole number. They're not considered like terms. Quick review, when I say radicand, we're talking about anything that's under the radical sign. Whole number is anything sitting way outside of the radical sign, and then our teeny tiny number right there is our index. First thing, you need to multiply the whole numbers and keep them outside of the radical sign. Multiply the radicands and keep them under the radical sign. Simplify any radicands if you can, and then always double check your answer. First, let's try this. We're going to take 4 times 6, and 4 times 6 is 24. We've now multiplied our whole numbers. Now we're going to take our radicals and multiply them together. And if you remember, when you multiply radicals, you multiply them and keep them under the radical sign. So 2 times 22 is 44. So I have 24 radical 44. The only issue now is we have to make sure that anything under the radical sign is fully simplified. 44 is not fully simplified, so let's make a good old factor tree. And I know that it's 2 times 22 and 2 times 11. Because this is looking for an index of 2, which is square roots, we're looking for pairs. So I do have a pair, and I have a lonely leftover. So you're actually going to have 24 times my pair of 2's coming out, and then my lonely 11 goes back under. So my final answer would be 48 radical 11. Now you would go back and double check by reworking the problem. There's no shortcut double check on this. You actually have to rework your problem. And even though it sounds tedious, you need to go ahead and redo it just to make sure that you didn't make a simple error. Let's try another example. First thing, let's take 13 times 6. And that's going to be 78. Now we're going to take our radicals and we're going to multiply the cube root of 9 times the cube root of 21. And when we do that, we're going to get another cube root. And this one is the cube root of 189. Big number. If it's a big number, it's probably not simplified. So here we go. Good old factor tree. And it looks like 3 can go into here. So we can do 3 times 63. 3 is prime, so I put a dot under it to keep track of it. Then I've got 9 times 7, 7's prime, and then I've got 3 times 3. All right, now I'm down to primes. And this is cubic, so I'm looking for groups of 3. And it turns out I do have 1, 2, 3 3's, and a lonely 7 left over. So my answer for this fully reduced is going to be cube root, 3 comes out, and the 7 stays in. Now that's for my radicals. Then I have to multiply it, put it together with my original 78. So it looks like I'm going to multiply 78 times 3. And when I multiply 78 times 3, I'm going to get 234. And I still have my cube root of 7. And this would be your final answer for the multiplication problem. Remember, you would go back and double check, rerun your multiplication, and check your factor tree. Make sure everything's correct. Make sure you didn't drop an index by mistake. Let's look at the next one. We've got for number 7, we're going to multiply 5 times 7, and we're going to get 35. Now we're going to multiply our radicals. So we're looking at the 4th root of 8 times the 4th root of 22. And when we multiply 8 times 22, we're going to get the 4th root, again, of 176. Big number, not fully simplified. Here we go with our roots. We're looking for a factor tree again, and this time I can do 8 and 22, 4 and 2, 2 and 11. All right, 2, 11, and the other 2, and then I have 2 and 2. I've got a whole bunch of prime numbers. I'm looking for an index of 4, which means I have 1, 2, 3, 4, a group of 4 2's, and one lonely 11 left over. So when I simplify my radical, that's going to equal still fourth root. And what's coming out is a 2. So I'm going to have 2 with the fourth root, and the lonely 11 is still back under there. Now that's all my radicals simplified, but remember we still have a whole number out here. He needs to go out front, and he needs to be multiplied by my simplified radical. So I'm looking at 35 times 2, and when I do 35 times 2, it's going to be 70. And I still have my fourth root of 11. This would be my final answer for my multiplication problem. Again, go back and double check your factor tree, go back and double check your index, and go back and check your multiplication. For the next one, whole numbers, negative 2 times 8, negative 16. Then I'm looking for my radicals. We're looking for the square root of 3 times the square root of 15. So 15 times 3 is going to be 45, and we're still looking for the square root. 45 is not fully simplified yet, so let's go ahead and break out a factor tree. 9 times 5, 5 is definitely a prime. 3 times 3, I've got a pair. So when I fully simplify my radical 45, it turns out I have got 3 coming out, 5 staying in, and I still have to multiply it by my negative 16, because that was my whole numbers originally being multiplied together. And when I do that, I'm going to get a negative number, 48, and I still have the square root of 5. And that is going to be my final answer. One more time, go back and double check, do your multiplication, and check your factor tree. Last example, let's try. I'm looking for this times this, and also my whole number times there. No, wait, I didn't have a whole number up here? Yeah, I do. If it's not written, it's assumed to be 1. So I have 1 times 2, which is 2. Now I'm looking to take the cube root of 25 and multiply it by the cube root of 15. So when I take those two, I'm still going to have a cube root, and now I'm going to have 375. Big number, which should tell you right there, break it down. We need to factor tree this. Well, I know it's going to be 25 times 15 because that's how I just created it. Then I've got 5 times 3, both primes, 5 times 5. And since I'm looking for a cube root, I'm looking for groups of 3. I have a group of 5 and a leftover 3. So out comes the 5. It's still cube root with my lonely 3 underneath. And remember, we still have our whole number up here that we have to multiply out. So 2 times 5 would be 10. And I have a cube root of 3. So this would be my final answer. Once again, go back and double check your multiplication, rerun your factor tree, make sure everything is correct. As a review, multiply only like terms, and we did that. We multiplied wholes times wholes, radicals times radicals. All the whole numbers need to be multiplied by themselves. All the radicals need to be multiplied by themselves. And remember, at the very end, you have to simplify any radicands that you can. And that's it for our look at radicals multiplying, a more advanced look.